All right, so we're going to look at 9.5, lesson 5 in chapter 9, the fundamental counting principle. All right, the fundamental counting principle. So go ahead and write that heading down. What is a fundamental counting principle? Well, we're going to find out right now. The fundamental counting principle, I'll just abbreviate it here, the fundamental counting principle, basically determines or tells you the amount of possible outcomes. Okay, so it determines the number of possible outcomes, how many things could happen, right? So uh, we know, for example, if you roll a dice, then there's only 6 things that can happen, right? 1, 2, 3, 4, 5, 6. Where the fundamental counting principle comes in play is when you have more than one event. So, for example, what if you were to roll 2 dice? Or if you were to flip a coin and then flip it again? Like, how many different outcomes are there? Now, when we were rolling 2 dice in a lesson before, we would say, okay, well, one way you could do it is you could say, well, I mean, let's say I roll a 1 on the first dice. Then on the second dice, I can roll a 1, I can roll a 2, I can roll a 3, I can roll a 4, I can roll a 5, or I can roll a 6. There's 6 things that happen if you roll 2 dice. Or that's one thing. Then I do it again for number 2. If I roll a 2 on the first one, then I can roll a 1, then I can roll a 2, then I can roll a 3, then I can roll a 4, then I can roll a 5, then I can roll a 6. Right? But we don't want to do all of this, and don't write this part down. We don't have to do that for everything we do. Instead, couldn't we just say that on one dice, I could get a 6. There's 6 possible things, and on another one, I could get 6. And if I multiply those together, I get 36 possible outcomes. If I would have kept going with this chart over here on the left, I could have. There would have been 36 different things, right? 1 and 1, 1 and 2, 1 and 3, 1 and 4, so on and so forth. But instead, what I can want to do is a fundamental counting principle takes this shortcut and it says, you know what? Let's just go to find out the total amount of outcomes, which is 36 total things could happen. So let's do an example here. I want you to write this one down. Okay. How many outcomes could happen? Okay. How many different outcomes are there if you toss a coin and roll a number cube? So, how many different things could happen? And again, this is important for probability because if you know how many outcomes there are, then you can tell how probable something is of happening, right? It goes hand in hand with like the probability part. So, what's the probability, or how many different outcomes could happen? Okay, well, let's start with the coin. Okay, when you flip a coin, there's only 2 options, right? Heads or tails. So if I flip a coin, there are 2 things that could happen: heads or tails. When I roll a number cube, right? That's or a die. Okay, there I can get a 1, a 2, a 3, a 4, a 5, or a 6, right? So there are 6 possibilities. So how many total outcomes are there? Just multiply these numbers. All you have to do is multiply these numbers. So say 2 times 6, there are 12 possible outcomes. What are those outcomes, right? You get heads and the number 1, heads and the number 2, heads and the number 3, so on and so forth. Then tails and number 1, tails number 2, tails number 3, so on and so forth. So how do we look at this in terms of probability? Well, let's say, for example, you were playing a game with flipping a coin and rolling a number cube, and the only way that your last turn, whatever, and the way that you win is if you can get a heads and a 6. So I flip the coin and I got to get heads, and I roll the cube and I got to get a 6. Well, remember, there are 12 outcomes, right? 12 outcomes. So the probability of getting a heads and a 6, there's only one of those. So the probability is 1 out of 12. The fundamental counting principle just determines the amount of outcomes. The probability part is kind of a separate thing. Let's do another example. Let's do another example that might hit a little bit closer to home. Have you ever had this problem where you think, I've got nothing to wear, like, or maybe I don't know what to wear, right? You look at your, your shirts, you look at your pants, you look at the socks you can wear, and you're like, I don't know, what should I wear? Well, let's just do an example, and I'll show you how we can determine how many outfits you actually have. So let's say, you have 8 shirts, you have 3 different kinds of pants, and you've got 3 kinds of socks. So you look in your closet, you got 8 shirts, 3 pants, and 3 different kinds of socks. So the question is, how many outfits can you make? How many different outfits could you make? All right. So again, we're going to take the amount that we have. So we're going to use the fundamental counting principle to figure this out. So I have 8 shirts to choose from. I've got 3 pants to choose from. And I've got 3 kinds of socks to choose from. So all we're going to do is we're going to multiply. You can take your calculator and you can say, okay, well, 8 times 3 times 3, right? And again, this is shirts, this is pants, and this is socks. If I multiply those out, 8 times 3 times 3, I get, put that in my calculator, 72 different outfits. So if you ever felt like, oh, I wore that yesterday, or I'm not sure, there's actually in this situation, there's 72 different ways you can arrange it, right? So it could be, for example, your black shirt with your jeans, with your, I don't know, your low socks, or your blue shirt with your black pants, with your long socks. Like, there's so many different possibilities. And actually, how many possibilities? We know there are 72 different outfits. 70 different ways. So the counting principle, again, just tells you how many things are possible, right? How many different ways. Let's do one more. Let's do one more just to make sure that we got it. Let's say you were going to go to a burger restaurant, In-N-Out or something like that, right? So you were going to order a hamburger, or rather a cheeseburger. Okay. There are 3 types of buns, 3 different condiments, or sorry, 2 different condiments, and 3 kinds of cheese. So you've got choices. You've got 3 kinds of buns. Okay, you can get white or wheat, or maybe like a sesame. You can get 2 types of sauce. Okay, you can either get ketchup or barbecue, and let's just pretend that you can't get the other one. And 3 types of cheese. So you've got American, Swiss, or cheddar. Okay. So a lot of choices there. I'm not sure which burger you would choose, which bun, which sauce, and which cheese you would do. But it seems like a lot of different choices. Okay, and that's why when you go to a place like that says we've got over, thousands of possibilities, is because you can make so many different combinations, right? That's why if you go to like an In-N-Out, there's so many different ways you can order your burger, right? I want grilled onions. I want animal style. I want no cheese. I want whole grilled onions. I want proteins. Like there's so many different things you can do. So many possibilities. So let's make this a probability problem. Okay. Let's say your dad says, "Hey, go order me a hamburger," and that's all the instructions they give you. And it's your job to pick the exact right one, right? Maybe he's got someone in mind, like, okay, I know which kind of burger I want, sauce, I know what kind of cheese I want, and your job is just try to guess. Well, what's the probability that you will get his order correct? What's the probability that you will get his order correct? Um, so let's say, for example, he wants. What's the probability that you are going to get if you're just guess? Let's say he wanted a white bun, ketchup, and and Swiss, right? Like, what's the probability that you would have chosen that? Well, let's think about it. What's the probability that you would choose a white bun? Okay. There are 1, 2, 3 choices. So the probability you would choose a white bun is 1/3. What is the probability that you would have chosen ketchup? Well, there are 2 sauces, so that would be 1/2. 1 out of 2, right? Because there are 2 choices. So you see what we're doing with the denominator on these. And what's the probability that you would have chosen the right cheese? Well, there's 1, 2, 3 cheeses, so that means 1/3. So let's do the math. Let's multiply these. Okay. The probability that you would have chosen the right one, that this burger would be the one, is 1/3 times 1/2 times 1/3. So 1 times 1 times 1 on top is 1. 3 times 2 times 3 is 18. You have a 1 in 18 chance of getting it right. Percentage wise, not great, but hey, there's a lot of different choices out there. So again, the fundamental counting principle is useful in determining how many different things are available there. Okay, how many different choices we have, and all you have to do when you're doing the fundamental counting principle, okay, is multiply the choices you have for each part. So on our first example here, if I've got 1 coin, I've got 2 choices. I've got a cube, I've got 6 choices. So I'm going to say, okay, 2 times 6 gives me my 12 outcomes, right? Our second example, if I've got 8 shirts and I've got 3 pants and I've got 3 socks, I can just multiply those to get my 72 different outfits. So that's the fundamental counting principle. It helps us to understand how many outcomes are possible.